Hello friends, welcome to my next tutorial on data wrangling tutorial series, the ultimate guide to data wrangling with Python using Rust Polars DataFrame to work with finance and supply chain data analytics. In first few videos we learned about Polars DataFrame and we created some dummy data for finance and supply chain. We also learned about data types, IO, context and expression. In today's video we are going to cover three important topics on expression: missing data, faults and aggregation. And in following video, we'll learn about functions and transformations. I want to call out that you'll find link to source code in video description below. And you can reach out to me at GitHub, Twitter, and YouTube. If you haven't already, please consider subscribing to this channel for more videos. As I mentioned earlier in this notebook, we are only going to focus on using Polar expression to work with data aggregation, missing data, and faults. This is the Jupyter notebook from previous sessions. And if you recall, we did create a finance and supply chain data model, DataFrames. You'll find link to previous videos in video description below. Here I am creating first data frame called department with following fields: ID, as of date, description, region, status, classification, type and category. If you run this, so it will create 15 different departments and 9 different fields. All right. Now let's go create another data frame called location. Similarly, these are the dummy data values with following fields: location data frame, ID as of date, some other fields. You can change it as per your requirement. But here I'm just creating a couple of the dummy location records. Similarly, one more short field called accounts. So as you can see, it created approximately 35 different accounts with different values here. Now this is synthetic data, and the reason I'm creating these 3 different chart fields so that I can put it all together and put it inside one, say, ledger data frame. So this is my, so think about ledger is a sales register kind of a data frame, and here I am creating 100,000 different rows with following fields. As you can see, it has fields called ledger and organization, fiscal year, accounting period, and it reuses a couple of the values what we have created in account, department and location data frame. And I included a numeric field called posted total. These are again random values here so that we can work with it. So if you notice that I created another similar data frame for budgets. So now we have 100,000 rows for actuals and 100,000 rows for budgets. So now we have enough data to work with. Now let's see first what we want to do. We want to take the DF ledger and we are going to change the data type. So as you can see, ledger, there are only 2 values, actuals and budget. So we are going to change the data type of it. Similarly for organizations, we are going to change it the data type. The reason we want to do this, because if you change the data type to say categorical, it's more effective so that you can do the aggregation later and more efficiently. Similarly, always pay attention to the data type. So for example, running in a numeric algorithm on string values is always inefficient. So please make sure that, whenever you're working with it, you use the appropriate data types. Another tip is when you're working with very huge quantity of data. So for example, in our case, we have a ledger data frame with 200,000 rows. What if your ledger data frame has like say 100 million or 1 trillion rows? So in this case, what do you want to do? You never execute the query directly. You always use the lazy compilation. Now what lazy compilation does, it creates an execution plan before the query is executed. So that your Polars expression can optimize the execution. So for example, in this case, you want to see the row count by ledger and fiscal year. So in this case, you want to do a group by. So all you did, you took the original data frame, you took the lazy compilation, and then you are doing the same thing, group by ledger and fiscal year, and you want to see the count and you want to see the posted total amount here. So as you can see, okay, it's complaining about the group by is deprecated. I'll fix that later. So now let's go change that. So pl.col, and I'm going to select that column by period. So you want to see ledger, fiscal year, accounting period, and you want to see that your posted total dollar amount here. So all I did, I grouped by ledger and fiscal year, and I displayed the count. I'm going to sort it by period, and then I'm going to take the sum of the posted total amount, and I'm going to divide it by 100,000 so that I can see that amount in millions. Otherwise, it's going to be too big of a number. And then once this is done, all you do q.collect. So q.collect is what actually executes that query. So here, if you run this and print this out, so it's still complaining about that. Let me fix that. So because group by is deprecated, you use group underscore by instead. So if you run this, it's going to display the result accordingly. So in essence, whenever you're doing the group by on massive data sets, always use the lazy compilation. Let's take another example using filtering. So for example, if you want to use the same data and you want to see the group by posted dollar amount by quarters. So in this case, what you can do, you can just filter the groups. You can create different groups. So in 1 year, there are 4 quarters. So what we will do, let's find our ledger data frame one more time. And as you can see, there are 12 different accounting periods. So I'm going to rerun this again. So first what I am going to do, I'm going to create the different groups based on the quarter. So just to recap, our requirement is to display the dollar amount by group. So in this case, we have 4 different quarters and we want to sum the dollars, create the mean or aggregation, whatever aggregation we want to perform by the quarter. So I'm going to define a function. There are 2 different ways of doing it. I'm showing you the first way of doing it. So I'm creating a function, say average by quarter. It accepts 2 parameters, from month and to month. And what it does, it returns a polar expression. Now what that polar expression is, so I'm going to select that posted.total column, and I'm going to filter that column only if the accounting period, so for example, I pass 1 to 4, 1 to 3, so that means first quarter. So if the accounting period is greater or equal to first, that means January, and less than or equal to 3, which is March. So this is Q1, and then I'm going to calculate the aggregation, that is mean on that. So just to recap, what this function does, it creates the group. It uses the simple polar filter techniques to filter the data, and it will create one group. Now, once we have defined this function, then we can use this function to group the data based on the conditions. All right. So again, just to recap, average by quarter, and it accepts 2 parameters, from month and 2 month, and it's just going to calculate the data based on those from and 2 months. So let's go copy paste this, the earlier data frame what we have created, out.lazy and group by ledger.physical year. Here everything remains the same, but what we want to do, we want to aggregate based on the quarter. So again, it's complaining about the group by. I'm going to fix that later. So here, simply what we want to do, so first way of doing it, simple hard coded way. So you say if accounting period is greater than 1, less than 3, that means January to March, you sum it up. And similarly, from 4 to 6 is a quarter 2, quarter 3, quarter 4. Or you can use the function what you have just defined earlier, average by quarter. So simply what it's going to do, I'm passing the values here. It simplifies the VAT. It's going to be slower, but I just wanted to show you the different ways of doing the same thing. So similarly, okay, now let's go collect that, and now this is going to complain about it one more time. Let me fix that group underscore by. Let me run this again. So as you can see, now it displays the dollar amount by different filter groups. All right, so before we move on to another topic, so let's review the pros and cons of these 2 different methods what I've shown you. One way is I'm using the polar expression, built-in expression inside that polar expression. So that's obviously is going to be faster. Whenever you use some kind of a Python function, say average by quarter, this is going to be the slower. So what I meant to say, please be aware, please be careful before defining such functions, because once you leave Rust Polar's data frame, you are leaving that polar framework and using Python, which may slow you down. So depending on the data types, it may be convenient, but sometimes it's, because Python, it works under only one GIL thread, so it might be slower. All right, so now let's go move on to another topic here. In this section, we are going to address how to handle missing data sets. So for example, you are working with one of the data sets. So let's take an example of the ledger data. And in one scenario, so for example, there are a couple of values which are populated with null or zeros. Or there's another scenario. So for example, you are creating the budgets. And budget is always based on the actuals. So for example, you want to create some rows based on the prior knowledge. So both of these scenarios, I'm going to show you with a couple of examples here. So the same data set what we have been using, the ledger data set, I intentionally inserted 38 rows with blank values here. So as you can, again, you will find the code into my GitHub repository here. It's very simply code. All I'm doing, I'm just took one accounting period and I'm inserting all those with the null values here. So first thing, as you can see, you can call the functions in null underscore count. What this function does, it tells you exactly how many rows are there for that particular column which has the null values here. So null count, simply what it does, it tells you there are 38. So in this case, it's telling you that there are 38 rows with the null values here. So how to handle this missing data? There are a couple of strategies you can apply. Very simply, what you need to do, you take the original data frame, and here I am calling that with column context because I want to retain the original values here. and simply create a new column. So sorry, take the original column where you want to fill the null, and then you use the method say fill null. Please go through the signature of this one. Very simply what you can do, you can populate it with 0.0. So there are different strategies, but in this case I'm showing you how to handle the null. That means I'm just replacing all the null values with the 0.0. So if you run this code, you will see that all of the null values have been replaced by 0.0. Here you go. All right. So, but this strategy may not work in some cases. So for example, in this case, in a data set like this, I want to fill it some logical values, which is like, definitely 0.0 is not doing it. So in this case, simply you call the same method fill null, but here you just want to carry forward the backward entries. So here simply you say fill null and you pass that strategy equals to forward. So what is going to do, what this syntax is going to do, is going to take the previous value and is going to carry it forward to the next values. All right. So as you can see, now this case all of the 38 rows have been populated with the some numbers here. Other thing what you can do, you can take a median of that particular column and you can populate all the null values with the median. So again, depending on your data set, there's another method is called interpolate. So what it's going to do is going to take the interpolation of that particular column and is going to fill all the null values with that appropriate interpolation data. So again, it simply depends on your particular data set. So please go through the signature of the fill null method. It provides you different kind of data strategies which you can use to fill in and fill in all the missing data. Now these strategies are very useful when you're working with the time series kind of a data or some kind of a data where missing numbers can create a lot of huge variances in your data. So in those cases, definitely these methods comes in very, very handy. All right, so I think that's pretty much it from the missing data perspective. Now let's go work on the folds. So in this section, I'm going to show you how you can use expression to apply folds. Now, polar folds is again a very, very useful methods in case when you want to do some complex aggregation. So by default, polar gives you a lot of different aggregation methods which you can use using group by. So for example, sum or minimum or mean. But in some cases, when you want to apply some complex aggregation. So for example, as you can see in this case, I'm doing simple aggregation, say mean, value or min or max. You can just apply, you can just regularly use the polar expression. But what if you want to do, so there's a different methodology. You can use pl.fold syntax. What it can do, as you can see in the screen, it's simply applying that function and is doing the aggregation on that simple. Here it may, you might be wondering why to even do that, but you will see once you see the complex aggregation, then folds becomes very, very useful. So let's go back to our original use case, what I was showing you, then it will make more sense to you. So in our ledger data frame, let's go back to our data frame here. So, okay, in our ledger data frame, if you recall, we have couple of columns, say asset, liability, revenue, net worth, and all of a sudden you figure it out that my net worth calculation is not right. So you want to do row by row calculation. So in this case, you have couple of methods. You can use the polar expression or you can use the polar folds. So for example, your calculation is say net worth equals to assets plus revenue minus liability. Just simple formula. So suppose you want to do by the row calculation or aggregation. In this case, you can use a pl.fold method and it becomes very, very handy here. So let me show you, how to achieve the same thing using pl.folds. So let's go back to our data frame. So balance sheet dot with columns, and as again you can see, I'm just going to copy the syntax which takes the literal value and the function. Actually, basically it's just a lambda function, but I'm going to copy this and I'm going to put this on our ledger data frame here. So balance sheet dot with columns, and I'm going to copy paste this function here, and then in this function, I'm going to replace the expression by this value. So say, take the column, say assets plus revenue, sum that up, and take the column, say liability, and do multiplied by -1. So eventually the formula will be assets plus revenue minus liability, and that's pretty much all I'm doing. So once you see, in reality, if you have like say 1 trillion rows and you want to do this kind of data operation, if you use polar expression, even this PL folds is even faster than using polar expression. So I definitely recommend you using PL folds if you're working with the massive data sets. I hope you will find this useful. There are a lot of other examples I wanted to show you in this video, but I think that's pretty much all right. That's pretty much it I wanted to cover from the missing data folds perspective. In next video, we are going to work on the data transformation. Thank you for watching.